Hello, families. We're about to start the unit on division, and this can be a very challenging unit. So, I'm going to make a video to kind of help you at home and also your students with how to use number lines to help us divide. And I want you not to be worried. The students will learn the traditional algorithm, which is what we were taught when we were younger, but coming from a place where I struggled with fractions as a student myself when I was younger, this is really good and this will really help them understand what they're doing when they divide. So before I start, I just want you to know that we did pass out books. We do have two sets of books kind of floating around. The Accelerated 6 and the Grade 6, they're very much the same. We ran out of these books, so your student may have the red one. If they have the red one, we're looking at units 4 through 6, the second book, unit 4. If you have the green one, it's going to be unit 3. And the green one is page 280. We're going to take a look at page 280. And if you're in the red one, it's that second book at the beginning, page 34. They're very similar. It's just that the red book has a little bit of extra stuff in it from 5th grade to help. Okay, so speaking of 5th grade, we are going to go back and take a look at something they learned back in 5th grade that we will touch on, but I am going to really push them into the number lines because it's a little bit more efficient. This is a great strategy when you're working with thirds, halves, and sixths. So back in elementary school, even as early as kindergarten, they've learned about these pattern blocks. So we have a hexagon, we have a rhombi, we have a trapezoid, and we have an equilateral triangle. And the students learned that 3 of these rhombi equal the same space as a hexagon. So each one of these little guys is a third, and 2 of them would be 2/3. Each one of these would be a half because 2 of them create a hexagon. And then our equilateral triangles, each one of these would be a sixth because 6 of them make a hexagon. Okay, so we're going to do a few little practice problems here with the pattern blocks just to kind of pull back where they were in elementary school. Okay, so one of the questions they will often ask is they'll kind of say it like this: How many 1/2s are in 4? So we'll see that question posed only because it helps students with division. This is basically 4 divided by 1/2. But 4 divided by 1/2 is very arbitrary to students. It's like, what does that mean, right? How many 1/2s are there in 4? If I have 4 wholes and I need to break it into halves, how many will I have? Now, some of the students can do this mentally. Some students have enough understanding about halves that they can say, oh, well, the answer is 8. But if they need to see it, this is a great way to do it. So I have 4 hexagons, and I know that each one of these is a half. So how many halves does it take to make 4 hexagons? And I like to use the duplicate tool just because it makes things a little bit faster. Okay, so I can just go down here to the double and just duplicate it. And then I can see when I'm done, I can count that there are 8 of these red shapes that equal the same as the whole hexagons. So that means there's 1, 2, 3, 4, 5, 6, 7, 8 halves in 4. So if I wanted this to be a division problem, 4 divided by 1/2 would be 8. Okay? And again, some students don't need that visual, but this is a great way to represent it. All right, so now we'll do one more with the pattern blocks. I'm going to do thirds, and I'm going to stick with 4. Okay, we're going to stick with 4, but we're going to change it to how many 2/3 are in 4. How many 2/3 are in 4? So again, this would just be 4 divided by 2/3. And we're going to delete these guys. Okay, I'm just going to kind of take one and move it over and just delete the rest. You can group them and delete at once, which is super nice. Yes. Okay. Now I want to know how many 2/3. Now that means I need 2 of these. That would be equal to the one group. Okay. So each 2 of these would be a 2/3. So watch what I'm going to do. I'm going to do this a very creative way so the students can kind of see it, and I'm going to color code. So I'm going to pull out and show that I can make a 2/3 here, right? I can make a 2/3 here. Then I have this next space, which is 1/3. So I'm going to change that color and I'm going to just make it red. Okay, so I can make one more and then I'm going to duplicate it, and I know I'm going to do one down here, and then I can repeat this. So if I duplicate this, I can see that's a 2/3. Okay, so here's 2/3, here's 2/3. The two red are 2/3. So I already can see that I can make 1, 2, 3 groups of 2/3 with 4. Now at this point, I could double and just stop there because I know that 2 times 2 is 4, and I've just created 1, 2, 3 groups. So I'm predicting that the answer is going to be 6, right? Because if I can do this one is 1, this one is 2, and then these two together make the third one, and I have 2 hexagons. If I double that, I should get the same thing over here. But again, if they need to see it, we can totally do that. All right, so I'm going to erase, and watch how easy this is. I'm literally just going to duplicate these. So I'm going to come down here and I'm going to click Shift, and then I'm going to duplicate. And then I'm going to show that there's another 2/3. Same here. Oh, 1, 2, 2/3. And then I'm going to take these two and do the same thing and show that I have, oh, that was funny. Hold on, I didn't duplicate this one. Let me fix that. Okay, then I can show that we have one group. This is one group of 2/3, 2 groups of 2/3, 3 groups of 2/3, 4 groups of 2/3, and then these two make the 5, and these two make the 6. Okay, so again, yes, it's a little bit of work. However, it is really good visual for students to see. We could also do this with sixths. Now, sixes are kind of tricky because you know that we could do 2/6, 2/6, which would be the same thing as 1/3. So if students have 2/6, they could literally just replace this with one of the rhombi. And then if we do 3/6, if I do 3/6, that would be the same as a half, right? So sometimes we can take shortcuts with our sixths. So you can see that would be half. But if you're working with 1/6, okay, 1/6, that would be 1/6 that we could have. So if somebody wanted to say how many 1/6 are there in 3, then we could figure that out. We could do 4/6. 4/6 come up a lot. That would be 2/3. So if you have 4 out of 6, 4 out of 6, then you have 2/3. So that would be another one of these rhombi. Turn it around. Okay, that would be my 4 triangles. The only one that would be kind of unique, like the 1/6, would be 5/6. So if I had to divide by 5/6, then I could use 5 triangles. And that would be very easy for the students to map out. Okay, all right, so this is, again, this is something they learned in 5th grade. We do a little bit of this at the very, very beginning of the unit, but mostly just exploring. But what I want to show you that we do a lot with is the number line. And this, oh my goodness, is just a lifesaver. Okay, so now I'm going to look back in the book. Okay, so I'm looking at these questions that say how many 3/4 are in 1. Now we're going to do these in Desmos in our class. So like these will be questions that we actually work out in class using Desmos, but they do have them in the book. The other nice thing I want to point out real quick about the book is that at the end of every lesson, there's a lesson summary that maps out the thought process and talks about how to solve these. If anything, the lesson summaries are the best thing about this book. Okay, so at every lesson they can look over the lesson summary. We have them digitally in Desmos, but you know, sometimes it's nice just to have a book and read it. Okay, so we're going to take a look at this one. How many 3/4 are there in 1? Now the students in the book, they have us drawing what's called tape diagrams. I like them, but I find that the number lines are the same thing but easier. Okay, so let me show you how cool this is. All right, so I want to write that problem. How many 3/4 are there in 1? So I'm going to go here to my line settings, and I want to make sure my fractions are in fourths because I'm dividing by fourths, 3/4. Okay, so it said the question was how many 3/4 are in 1? How many 3/4 are in 1? this is going to be the same thing as 1 divided by 3/4. Okay, so I'm just going to keep this up here so we have it. And I'm going to use my marker and I'm going to find 1. Okay, so this is where I need to go. This is my whole 1. And I want to see how many 3/4 are there in 1. Watch how cool this is. All right, so there's this little line hopper down here, and this bar can be adjusted. So I am going to adjust it to be the width of 3/4. Now, you can turn this on or you can turn it off. I prefer to leave it off, but you can see that it is 3/4. But I'm going to turn it off, and I'll show you why in just a minute. Okay, so I can see that I can make one group of 3/4 for sure, but then I have this little space left over. Some students think that this is actually 1.5, but it's actually not. And let me show you why. Okay, if I pull up another one, see how I have 2 now back to back, I'm going to draw a line where the 1 is. See the 1 here? Okay. So I have one whole, and the reason why I turned the labels off is for this reason. I have one group of 3/4. So I know my answer is going to be 1 and something. This is going to be my mixed number, my leftovers. Well, look, if I just do another line here, I can see that this 3/4 has been divided into 3 parts, and only 1/3 of the part hits the 1. See this? So here's 1, 2, 3. See the 3 parts? Only 1/3 of this 3/4 is actually in my problem. So my remainder is really 1/3, not 1/2. And that's what gets a little tricky, or 1/4. So sometimes it's helpful to use this number line to help to what is the remainder, to help understand what the remainder is. So I'm going to show this to you one more time, but I'm going to use a different number. Okay, so 1 divided by 3/4 is 1 1/3. Now, I am totally fine with the students checking with calculators. I would prefer that they not use a calculator, but I want to show how we can check our work. Okay, 1 divided by 3/4. So I'm going to put 1 in here and I'm going to divide it by 3/4. This is a double fraction, but you can see that this is the 3/4. Now, if students want to do it in decimal form, 1 divided by 3/4 would be 0.75. The answer is 1.333333333, and students have been learning that 1/3 is equivalent to that repeating 3 decimal. So my answer is 1 1/3. Okay, 1 1/3. Now we could also write that as 4/3. Okay, 4/3, but 1 1/3 is a perfectly good answer. All right, let's try one more. I'm going to totally reset the screen, and this time I'm going to do how many 2/3 are in 3. Okay, how many 2/3? So now I need to change to my thirds. Okay, so the question is, how many 2/3? How many 2/3 are in 3? Or 3 divided by 2/3. This is like a fact family. This would be like 3 times 5 is 15. 15 divided by 3 equals 5. All right, here we go. How many 2/3 are in 3? So the first thing I want to do is find 3. Okay, that's where I got to get to. And then I can see that I need to count by 2/3. So I'm going to use the hopper tool and I'm going to shrink it down and line it up with 2/3. I can even turn it on to check, make sure I have 2/3, but again, I would turn it off. Okay, so here's my 2/3. So now I can use the duplicate tool, which is amazing, to duplicate my 2/3. So I have another 2/3, okay? And then I'm going to duplicate and I have another 2/3. And I'm going to duplicate it and I have another 2/3. Okay, now I got to stop because look, if I do one more, I'm going to go past 2/3. I'm going to pass 3. So let's see how many we have. 1, 2, 3, 4. Okay, so I know my answer is going to be 4 wholes. 4 whole groups of 2/3 plus some left over. Again, just like the last problem, I got to be careful with this remainder because what is this? Well, all I have to do is get one more 2/3 up here. Okay, line it up, use that marker tool and see, oh look, there's 2 parts and only one of them I'm using. So this would be half, right? So if I use that 2/3 and I line it up, I would need another whole, and that would get me to 3 1/3, but I'm only using half of that 2/3. So my answer is 4 1/2. Okay, 4 1/2. All right, let's check with the calculator. So I'm going to come over here and I'm going to do how many 2/3 are there in 3? I'm going to do 3 divided by 2/3. 3 divided by 2/3, and it's 4 1/2. Very nice, see? All right, so using this number line will really help. All right, we're going to do one more. How many halves are in 2 3/4? Now, this one is tricky. How many halves are in 2 3/4? I'm going to reset the screen and I'm going to think about that. How many halves are in 2 3/4? Well, if I look at 2 3/4, okay, I can see that this is broken down into fourths and I'm going to be dividing by 1/2. And my denominators are not the same, right? So it makes it easier in this type of problem without using the standard algorithm if our denominators are the same, because we're skip counting. We're counting up how many 1/2s are there in 2 3/4. So what I would do is rewrite this. And this is something, again, that students should have a good understanding of. 1/2 is the same thing as 2/4. So if I want to keep my denominators the same to make it easier to skip count, I can easily turn 1/2 into 2/4. Okay? All right, so here we go. We're going to go ahead and use that instead of half. So I'm going to come down here to the number line. I'm going to change it to fourths, not halves, fourths, because I know that I have to get up to 2 3/4. So the problem is 2 3/4 divided by half. That's the original problem. To make it a little easier, I'm going to change the 1/2 to 2/4 so I can count by fourths. Keep my denominators the same. All right, here we go. We're ready. So how many of these 2/4 are there in 2 3/4? So I'm going to come down here and I'm going to make a 2/4, which is the same as a half. Again, turn it on to make sure you have the right size, but then I would turn it off and then we can duplicate. Okay? And then if you grab it at the middle, it doesn't resize it. All right, so now I can just count up. This is repeat addition, guys. We're just counting up. We're just figuring out how many 1/2 pieces can we make in 2 3/4. Okay, lots of them here. Keep going. All right, I'm going to stop there because if I make another, I'm going to go over, right? Okay, so I know my answer is 1 2 3 4 5. So the answer is 5, but there's a leftover, okay? So if the students get the answer 5, I mean, that's close, that's partial credit, right? Okay, so now let's figure out what this leftover is going to be, right? Because we still need to get a little bit further to get to 2 3/4. So I'm going to do another hop. We don't want to change the size of our hopper. We got to keep it all the same size, okay? All right, so now that I see the hopper, I can draw the line. See the line? This is great. This is why I love this tool. Here's the line. That's where I need to be, right here. So I have two parts. I'm using one of them. So this is a half, right? So I'm only using one of two. So my answer is 5 1/2. Or if you want to leave it as an improper fraction, this would be 11 halves. That would be another way we could write it. Okay, 11 halves. But this is the answer. Okay, now I know my denominator has changed, but that's okay because we could say 5 2/4. Same thing. 5 2/4 is the same thing as 5 1/2. Okay, so let's check it with a calculator. So I'm going to come over here. Now this one's tricky with the calculator because you see this is a mixed number and Desmos doesn't understand mixed numbers. So one of the things they might have to do if they want to use the calculator and 2 3/4 is make it a fraction greater than 1. We used to call them improper fractions. So they know how to do this, or they at least should know how to do this. They learned it in like 4th grade. So it's going way back. But we have two groups of 4, right? Two groups of 4, which would be 8 plus the 3 left over, 9, 10, 11. So this would be 11/4. Okay, now I can use the calculator. 11/4 is the same as 2 3/4. So I can come over here and type in 11/4. Now, I'm got to be very careful. Make sure you go outside of the fraction, and we're going to divide by 1/2. And we're going to divide by 1/2. Okay? So it's a stacked fraction, 5.5, which is what we got, 5.5. Okay, now let's look at it in decimals. Let's say we want to convert this to decimals. 2.75, which is 2 3/4, divided by zero point 0.5, which we could do. We could also do it this way to double check our work. 2.75 divided by a half, or zero point 0.5, and I got the same answer. Okay, I can even look, 11 halves, which is what we set as an improper fraction. This is an outstanding way to help students divide with fractions. Dividing fractions can be very tricky, and I will be teaching them the standard algorithm. But before that, we are going to spend a week. We're going to spend a week really practicing how to use this number line because it's so visual and it is so helpful for students. I hope this video helps you. Encourage your students to watch it because we will be practicing this a lot in class.